Ken Forrester, Executive Director at Momenta. Welcome to our Digital Thread podcast, produced by, for, and about digital industry leaders. In this series of conversations, we capture insights from the best and brightest minds in digital industry. They're executives, entrepreneurs, advisors, and other thought leaders. What they have in common is, like our team at Momenta, they are deep industry operators. We hope you find these podcasts informative, and as always, we welcome your comments and suggestions. Good day, and welcome to episode 234 of Momenta Industrial Impact Podcast. Today, I'm pleased to host Dr. Matthew Carr, CEO and co-founder of Luffy AI, the first adaptive AI platform for industrial optimization. Momenta just led the recent funding round for Luffy, our 55th portfolio company. Matthew is an experienced data scientist and entrepreneur, having worked across AI, data science, fusion physics, and scientific research. Prior to funding Luffy with Alex Meakins in 2019, Matthew worked as a fusion physicist at the UK Atomic Energy Authority. At UKAEA, he developed fusion reactor simulation models and conducted novel research into Bayesian Inference algorithms for estimating the reactor state and performance. Matthew obtained a Doctor of Philosophy degree in plasma physics and nuclear fusion technology from the University of Sydney in 2013, completing a Bachelor of Science degree in physics at UNSW. He is an expert in all aspects of data science, neural networks, deep learning, and simulation and modeling. Matthew, welcome to our Industrial Impact podcast.
Thanks, Ken. It's a pleasure to be on your podcast.
And a pleasure to have you. What a great bio leading into this. And you and I know it took me more than one try to get some of these terms correctly, but it should be a very interesting podcast and, well, funding that we've done in most recently. So, we call this the Digital Thread podcast. And really, this is about one's own personal digital thread in terms of the defining interests and experience that brought them to this point in life. What would you consider to be your digital thread?
That's a fantastic question. I think I've always had a passion for industrial technologies and power generation. I've also been very passionate about the energy transition and seeking out technologies I can work with that push towards decarbonization and Industry 4 and even Industry 5 levels of automation. And it was always a pretty even mix of curiosity for physical systems themselves, the data science algorithms that might enable new types of operation and efficiency. In my undergraduate degree, I originally studied electrical engineering and spent a bit of time around solar cell manufacturing facilities and wind turbine research. I then transferred into physics and mathematics so that I could go much deeper into the processes themselves and the algorithms that control them. And then ultimately, I moved into fusion physics for my PhD studies because I saw it as a fantastic way to combine my passions for advanced engineering, physics, and data science. And it was sort of during my PhD that I ended up, through accident, discovering startups. A former graduate of the lab had founded a startup with my PhD supervisor. They were trying to make a new type of electric radiation source for producing medical isotopes and also detecting contraband at airports. And it was just a fantastic challenge. I was initially given just a part-time job as a scientist there, but ended up running that small startup for 2 years. And when I started, it was just a benchtop experiment. It just looked like a lab, a benchtop lab exercise. By the time I finished there, it looked like a product. We actually had it in a travel bag that looked a bit like a ski bag, and you could carry it around and easily sort of demonstrate it. And the nice thing about it was a radiation source you could turn on and off. And from that experience, I just fell in love with startups because of the off-the-wall innovation and creativity, the challenge of what you're trying to do with the disruption, and also sometimes even just the chaos of needing to solve problems quickly and efficiently because you don't have those luxuries like you might have in a bigger company. So that really seeded my interest in entrepreneurialism and combining that with, deep tech research and ideas. From there, I moved on to my postdoc at the UK Atomic Energy Authority, where I was working at the world's premier fusion research lab in the Cullum Science Centre. There they have JET, which is the world's largest fusion reactor and burning at the hottest temperature, this side of the Milky Way. And that was an amazing opportunity. I would venture to say that fusion reactors are the most complex machines ever developed. They have literally tens of thousands of sensors and hundreds of actuators. And I was working on simulating the reactors and trying to infer their state with the eventual goal to optimally control them for the highest levels of fusion efficiency. It was at UKAEA that I developed my understanding of the need for this new types of data science and modeling and AI tools so that we could better infer the state of engineering machines and how we can control them, which led ultimately to form Luffy as a team spin out from the lab.
I'm always a big fan of cross-domain thinking. And in your case, I'd also tie convergence in there because of how all of these vectors have come together to really help you found Luffy. You made quite a broad jump from nuclear fusion to what I'll say is generally industrial AI, which of course is our investment thesis. It's quite a broad jump in there. What attracted you to industrial AI in the end?
That's a great question. It was actually quite a natural jump because of the experience we had from modeling and controlling fusion reactors. We could see all of the problems needed to solve in fusion. We sort of really needed this sort of advanced simulation and modeling and control systems, and we figured it would be the same across manufacturing and robotics. I could see that from the conversations we were having. But in terms of what really attracted me to sort of actually, make that jump, it's because of the potential for impact and it just being massive. Manufacturing underpins, all of society. It builds all of our foundational materials from concrete, steel, glass, right through to computing components and electric vehicles. But unfortunately, because of the rising labor costs and energy costs, we've seen a lot of these industries go into decline and migrate to economies with cheaper labor, which is a sad and worrying trend. But I think AI is one of these key technologies that could actually reverse that trend. It will allow us to increase the automation levels in our factories, make our processes more energy efficient, and incorporate more recycled materials, building the circular economy. I think innovations in industrial AI could eventually allow us to repatriate a lot of manufacturing that is left and make it competitive again. And it's not even just about all these other benefits. McKinsey has estimated there's almost $1 trillion in value creation possible in manufacturing if we can really develop and realize these technologies. It will create new high-tech jobs and enrich our economies.
I think you've done a better job and more eloquent job talking about the Momenta investment thesis than we've even done on our website. So I'm going to have to go back and get the transcript of this. But effectively, same trend, right? Talking about reshoring as a macro factor, but against, labor shortages in the markets and looking at really leapfrog technologies as, you have these reshoring initiatives. And AI clearly over the last 18 months especially has now emerged to be probably the leading leapfrog technology in so much of this. So great time to start a little company called Luffy AI. So tell us about the origin story of Luffy.
Well, I met my co-founder, Alex Meakins, actually on my first day at UKAEA. We were sharing an office together and just hit it off right away because of our shared interest in sort of deep physics problems, data science, AI, and all of the sort of challenges we could see in fusion and robotics and manufacturing. But during that period, because this was sort of 2013 to 2015 when we were sort of, first meeting and collaborating and working together, that's sort of when the deep learning revolution was happening that was sort of led by DeepMind, and it was almost hard not to hear about it every other week in the media. But what really fascinated me was the differing levels of maturity and adoption across different application areas. Supervised learning technologies for image and speech recognition were reaching commercialization and in some cases even reaching maturity. You had basic technologies there being cloned into every industry you could think of. But technologies for control, such as deep reinforcement learning, were just still stuck in basic research. So if you visit a factory that's adopting AI, it's likely you'll see lots of cameras doing defect detection and a cloud-based dashboard that is scraping lots of data and doing predictive maintenance. But if you look at the control system, I'll bet you money it's a traditional control technology like PID or MPC. And we think the reason for this is that supervised learning techniques are just too data hungry. They require vast data sets for training and are just too expensive. Or the data is biased to the standard sort of operating modes favored by the plant operators, which means it's very difficult to train a general control solution. And then also we're seeing sort of a lot of research and experimentation into deep reinforcement learning, which is, training based on simulation, for example. But these digital twins are never 100% accurate, and then they often fail to transfer into the real world. Now, my co-founder, Alex, he'd done all of his PhD research into evolutionary AI techniques. So he knew that these more biological approaches allow you to make adaptive AI systems and really free up some of the constraints of traditional AI technologies. And so after thinking about this together and looking over it, and the algorithms for a couple of years and doing our own research, we believed that this was the key to solving these problems and allowing you to make an industrial AI platform technology that can really scale and compete with traditional control. So we formed a team spin out from UKAEA in late 2019 to build an adaptive AI platform technology focused on this goal.
Now, when you talk about this, the unique technology that underlies Luffy AI, you guys mentioned biologically inspired techniques such as neuroplasticity and neuromodulation to make neural networks that can truly learn and adapt at the edge. Tell me, how does this adaptive intelligence or adaptive AI, as you referred to it a moment ago, differ from these more traditional forms of industrial optimization or control?
Well, the most widely used control systems today are basically PID controllers, which is essentially a tuned set of mathematical equations. You have to sort of tune them for each system, in question that you're going to try and deploy it on. And it may start off working perfectly, but it's only as good as that calibration. If you have any changes in the system, like wear and tear or failures in components, or even just variations in the feedstock materials, it can take it away from that optimal tuning region. And then this can lead to degraded performance, which ultimately means wasted energy and more variable product quality. There's another more advanced class of controllers called MPCs, or model predictive controllers. And these use physics models to sort of simulate the system at each time step and try and work out the optimal control actions to take. These systems work really well in processes where you have suitable time dynamics and accurate physics models. But unfortunately, still for a very large number of processes, you just don't have these accurate models, or they're just too dynamic, or it's even just too expensive to maintain and sort of, operate these MPC systems. So the majority of industry is still using simple PID, mathematically based controllers that are susceptible to these tuning issues. So adaptive AI really overcomes all of these problems by allowing us to make a new class of neural network that can learn and adapt at the edge. It can use, these biologically inspired mechanisms such as neuroplasticity and neuromodulation, which are embedded in the network, to use sort of real-time feedback from these systems to tune themselves to that machine in question. It sort of uniquely tunes itself to that machine. So it's a bit like embedding an optimization loop into the neural network itself that can tune based on all that live data. And so this overcomes all the problems in supervised learning, where the networks are normally static after training, and with a lot of the supervised learning systems we've seen, manufacturers are training it on some large data set they've curated, and they might see early results, but very quickly, something changes during operations and it just drifts out of the data set they had. And so then they have to go back to the cloud and retrain on new data, and then they see these sort of performance gaps again. So the real advantage of this adaptive AI technology, like what Luffy is developing, is that we can start off training on digital twins of the process that don't have to be, precise models. We just need to understand what all the main variances are. Usually these are digital twins or simulation models that, manufacturers or operators already have. But then when we train on these variances, we can then create a neural network that when deployed will tune, adapt, and, sort of learn the system at the edge.
I guess probably one might say to demonstrate the power of your solution set already, your solutions span industrial processes, robotics, and even drones. So where is the common solution thread in these different domains?
Yeah, so we're currently testing the system across a wide variety of application domains. But what we tend to see in common is that these are all dynamic, nonlinear control problems. You have some kind of process that can change quickly, or the output value is, the value of the outputs from the process are highly sensitive to the way you control it. And it's almost always the case that customers have been facing challenges from the limitations of the PID control that they already have. It probably basically works, but only when it's correctly tuned. And then because of any changes to the system, or even just their business goals, rising energy costs or increasing use of recycled materials, this is all pushing them and the control system to its limits. And so these customers like us believe that AI control could solve these problems for them and enable them to get new operating modes, or enable them to access the full potential of their hardware, which is something they're not currently able to do.
So perhaps as another form of demonstration here, what have been some of your early wins?
One of our first manufacturing customers was a UK-based OEM, equipment manufacturer for producing high-end aerospace and automotive composite parts. It's a process where you have this sort of mold tool where you lay in the composite materials and the resins, and then you take it through a heating and cooling process to cure these parts. And because it's very sort of high-value parts that are made in batches, you might only make 100 of these parts at a time. The quality of the output parts is sort of very sensitive to the way you run the machine. So they had a traditional PID-based tuning process that would allow them to tune it, each time the part changed or the mold changed. And, they can get good results, but it's a bit sort of labor intensive or requires expert users. So what they really wanted from us was an AI-based system that would allow them to make any user a hero. You could take any apprentice or any person who's, sort of new to using this equipment, and instead of needing 3 or 4 years of sort of, expert level experience in the machine, they can just run it first time and make great parts. And that was essentially the mission. allowing us to come in with this AI control system that can sort of self-optimize to all the variations in the mold tooling, the materials that are going into it, and the sort of part demands for the end customers. So when we developed this AI control system for them, tested in this sort of test manufacturing line, we managed to see a 10% improvement in the energy efficiency of how the AI was running the device. And this was just sort of straight off the bat. Then we also saw a big sort of improvement in the temperature span, across the sort of device service. And the real achievement here was that this was just out of the box. You're just plugging in the AI and it's sort of self-tuning and self-learning on the fly. So yeah, we're now going through commercialization with them. And off the back of that trial, we were able to sign some new blue chip customers I'm very excited about. Unfortunately, I can't announce them just yet, but I hope we will have some very interesting developments over the rest of this year.
Well, I know you've got a great pipeline full of opportunities. I'm curious, though, use an old analogy. I'm sure people don't go through the phone book looking for advanced AI or autonomous or Luffy, even for that matter. I'm curious, how do your clients ultimately find you? And more importantly, how do you engage with them to solve these industrial AI challenges?
I think that's a great question. Obviously, a lot of these companies have already learned through their experience that they're looking to try and adopt AI technologies. But what they're seeing is, of course, a lot of professional services or a lot of customization, sort of very custom made solutions. The big differentiator for Luffy here is that it's a platform technology, and we actually have a product library that's sort of growing over time for a whole range of industrial processes. So when customers end up coming across us, it's easiest actually if they already have a process in mind that's in our product library, and then we can then just sort of export this AI controller that then can be self-tuning and self-adapting in their process equipment, and sort of easily enabling them to adapt and sort of adopt the technology and scale. If they have a new process that's maybe harder or not one we've sort of worked with before, then what we would typically do is work with them from a digital twin they might already have of their process. And so we just typically run a general sort of training process on these digital twins. And from there, again, because of the adaption capabilities of our networks, it means they transfer into the real world reliably and then can also easily transition from one piece of hardware to the next piece of hardware of the same class.
Now, it sounds like you've already got some best practices in terms of end users and usages there. So how do you know when an organization is truly ready to adopt your solution? And I guess more importantly, what best practices have you seen in your clients realizing the value of Luffy AI?
That's a great question, Ken. I think a common thing we see is a high level of digital maturity. These organizations off the back of the Internet of Things revolution, they've already invested a lot in sensing and digitalization. And so that's really sort of improved their overall understanding of their plans and what's happening. But typically what happens is all of that sensing can't easily be connected back into the older, PID and NPC systems, and be ingested for control. So these are operators realizing already that they need to move to something more advanced and some kind of AI-based system. They'll already have control systems in place. They might already have partners for digital twins and some kind of digital twin solution. And they've probably tried some supervised learning techniques already, but found they couldn't do everything they wanted or they were more limited. As I mentioned before, maybe got stuck in sort of certain areas of not getting deep enough into control. It's important to say here that we don't need, advanced data science teams in that organization to work with and adopt our technology. We typically can just work with the engineering models and control engineers you already have in your plant. And so it's quite easy for us to sort of meet you where you are and sort of help you sort of improve and build an AI solution. Another thing I would say is that it's, in terms of best practice, it's very important to take a more holistic view of the overall process. I think what we've really learned as well from working with plants is you need to think about a lot more than even just control. You need to think about the operators and the people that are running the machines and how are they going to interact with this and how are you going to make it more user-friendly for them and really empower them, because that's really the key to driving AI adoption in this space.
Now, when you say AI adoption in this space, Momenta has been investing in industrial optimization for over a decade now, but we've often noted that few of these systems are truly used in an autonomous, if you will, closed loop application mode. You mentioned PID, always closed loop, right? MPC, largely closed loop. But we notice when it begins to touch on AI that it's largely operator recommendations many times in that regard. We're seeing that change, and it sounds like you are too. So I'm curious, what are you seeing as some of the key motivations for many of your clients finally considering closing the loop on this now?
I think it's a broader combination of changes, and some of which are like almost economic and societal beyond just technological. It starts with the Internet of Things boom that I mentioned a moment ago, which meant there was this big investment in digitalization, which from what we can see, a lot of factories haven't been easily able to ingest all of that data and even really use it and reap the benefits of it. But also just general increasing economic pressure to improve efficiency and competitiveness, with the cheaper labor economies. And this is really going to drive a lot of manufacturers to innovate and really push the limits of their sort of processes over the next decade. There's growing pressures from society to decarbonize and reduce emissions. This voice is sort of only growing in manufacturing and pushing manufacturers to look for cleaner and more efficient ways of operating. And then you've also just got general pressures to move more to agile Industry 4 practices and Industry 5 practices, being able to easily switch product grades, add more recycled products into their sort of input streams, and also just more generally adapt to market conditions. All of these factors are really driving interest and investment because it's really challenging the control systems. And if you can't get to that next level of control, you just won't be able to do all of that and you won't be competitive.
One of the companies we work with talks about a general trend of automation to autonomy. And what we've seen in those two, you could call them extremes of maturity, is it's more like automation to augmentation to agility to autonomy, right? Yeah. There's these kind of stopping points along the way. And so I think it's interesting when you start to talk about agility and how important that plays into it. And that's really what you're speaking to in this regard. And I think from an Industry 5 perspective, certainly augmentation as well, i.e. considering all aspects, all stakeholders in your process, especially the operators, right? And in some sense, the environment. So look, this has been a great conversation. As we wrap up, I'm always curious how you maintain your edge as a leader. Any recommendations you'd like to highlight for the audience at this point?
Yeah, so one of the first books I would recommend actually is probably not a common one that's recommended, but it's called Value First, Then Price. And it's actually originally written about value-based pricing. But why I found it so influential to me is because it gets you thinking about the value creation for your end customer. It gets you really laser focused on trying to understand, how is this person actually going to benefit from what I'm doing? How can I make that quantitative? What benefits are they going to get in terms of economic or energy efficiency, decarbonization, whatever it may be? And how can I really focus on making that clear? Because once you can make the value creation clear, everything else, it almost feels like will flow naturally from that. And it also sort of helps you with your selling and almost makes the return on investment hopefully a no-brainer. So I found it's been very helpful in making me more laser focused on using that to kind of assess which processes we can add the most benefit to and where is the value creation going to be. And then more generally, I guess I've found it really beneficial to learn from stories, other people's entrepreneurial stories. So I love all the biographies, so things like, the Jobs biography by Isaacson, or, there's a few on, I think, Jack Ma from Amazon, Elon Musk, all the others. Just reading other people's entrepreneurial stories is always really interesting for me because you learn about the struggles that they encountered and also the mentality and commitment it takes to be a successful entrepreneur. And then, of course, beyond that, I'd recommend as well some of the other thought leadership books that are very classic for startups. So like Crossing the Chasm, for example, is a classic.
What impresses me, Matthew, and this goes back to the very beginning of our discussion, is for somebody who, by all definition, should be at the epitome of deep tech, right? Nuclear physicist, if you will, PhD. You gave recommendations very well-rounded about truly business, right? And how to apply that technology to a better purpose. And so I think it probably says a lot about how well-rounded you really are, and probably one of the key reasons beyond the great technology that we invested in Luffy AI. So
thanks, Ken. That's a great compliment.
Well-deserved. So Matthew, look, thank you for this time and these great insights for us today.
Thank you, Ken. It's been a pleasure.
All right. So this has been Dr. Matthew Carr, CEO and co-founder of Luffy AI. Thank you for listening. And please join us for the next episode of our Industrial Impact Podcast. We wish you an impactful day. You've been listening to the Momenta Digital Thread podcast series. We hope you've enjoyed the discussion. And as always, we welcome your comments and suggestions. Please check our website at momenta.one for archive versions of podcasts, as well as resources to help with your digital industry journey. Thank you for listening.